you need more of a social life. So welcome to analytics. There's Jamie. Yes.
None of the above.
None of the above. Might be here to correct me. Do I have handouts for everybody there? This is either a condensation of a 3-hour class down to a 40-minute discussion, or an expansion of a 10-minute speech that I gave this in Toastmasters up to 40 minutes. So we're going to be someplace between 10 minutes and 3 hours tonight. But Jamie, if you can give me a time in about 30 minutes here so that I can start wrapping up, that would be great. Otherwise, we might just keep on going. Awesome. Well, let's look at what we're going to talk about tonight. Again, we narrowed down the objectives a little bit, but we want to just talk about the word analytics. By the way, I should pause. We should do some introductions here before I even get into the content. Again, I'm Craig. I'm a recovering accountant. I was a CPA for 6 years and a banker for 17 years. I found that work way too exciting, so I got into the wonderful world of data. And I've lived there now since 2009 as a consultant, as a reporting and analytics consultant, really. So I find this stuff kind of fun. And I thought I just want to know everybody's name again for sure. But Lou, Matt, Sandra,
yeah.
Sandra,
yeah.
Al, Jamie, Julie, Derek. Okay, good deal. Good deal. Well, again, let's just take a look at where this course is going to go. We do want to talk about the word analytics. It's a word that we hear everywhere these days, whether it's news, whether it's business, whether it's salesman, whatever else. We hear the word analytics a lot. We want to talk about whether our organizations or ourselves are ready for doing some analytics. And again, how we can maybe recognize some of the tools that are used in doing analytics. Analytics is a broad term, covers a lot of ground here, so we're going to kind of narrow that down a little bit, define a little bit more tonight, and talk about how we get there. And again, not just the tools, maybe not just the software, what kind of people do we need in order to do analytics, and that's kind of thought processes. So first, what do we mean by analytics? We're going to expand on all these topics in the next few slides, but I'm sorry to say that it does usually involve some sort of math. Good news is you don't necessarily need to do that math yourself. Usually that's built into the tool these days, the statistical analysis and such, so you just need to know how to run a tool usually. But you do need to know what you want to measure and how you want to measure it and how you want to look at it. We'll talk about the types of analytics. There's a different flavor to the different types. Big data is a buzzword we hear a lot about, so we'll talk a little bit about big data. And we'll talk about the presentation of information, which is almost as important as the calculation of the information itself. Looking at that, too, in terms of math, when we think about analytics, a lot of it is aggregations. If you've ever run an average of something, you're doing some sort of analytics. It might not be fancy, but it's analytics. You're breaking that granular, taking that granular data, aggregating that up to different levels, looking at it in different ways, and summarizing that in some way that you can make sense of it as opposed to just looking at a long list of numbers. When you look at a long list of numbers, most people can't look at it and see any kind of patterns. You just see numbers. You want to see that broken down by types of the data, by time periods of the data, so that you can see what it's doing in relation to other components of the data. So we're aggregating that. A lot of times we're working with some probabilities. What's happened in the past, can we translate that into the probability of this is going to happen in the future? And again, there is some statistical analysis involved to some degree, to varying degrees. We can do analytics with very little statistical analysis and very little training in statistics. But the tools that we use might do that work for us. There are three main types of analytics I want to talk about tonight. First is descriptive, and that's what's happened and why. So this is kind of our classic historical reporting. You might get any kind of reports on your system that tell you what your sales were last year, what your customers did last year, that sort of thing. But that's just telling you what happened. It's useful information because we want to know that, and it's the way we've operated our businesses for years. But the goal these days is to get to predictive analytics. That's what we hear a lot about, and we see it all the time. Where do we see predictive analytics? Examples? Day-to-day life. This is where you speak, and predictive analytics.
You open and close to the stock market after hours to 4 hours.
Okay.
Predictive.
Okay, predictive.
Mm-hmm.
Yep.
Mm-hmm.
In terms of interactions in retail, maybe.
Mm-hmm.
Right.
They're recommending a certain product.
Yep.
Yep.
So they're always recommending a certain product to you.
Yep.
Right?
Trends in retail, that kind of thing.
Yep. They're they're very often trying to get in front of your decision making so they can present you with things that they want you to buy or things that they want you to do. And that is all, again, done by looking back into the past, looking at the patterns in the data, comparing that to the current data and where you are and what you're doing, and then saying, kind of, people that are doing what you're doing would also do this. We'll dig into that a little bit here too. And then the grail here is prescriptive analytics, where that's kind of combining the historical and the predictive and saying not only what has happened, not only what we think is going to happen, but this is what you should do right now. There are a couple small examples of prescriptive analytics as well. This would be, I'm not going to explain the spreadsheet. This is just to remind me to talk about this thing. This is a model that I built for a hospital to predict to look at their RN staffing, because they felt that it was they wanted to make sure that they were staffing appropriately for patient needs. There's a certain level where you're required to staff, but they were staffed way above that, so they wanted to kind of manage that. So we took, you tell me where we're getting into the different types of analytics now, but we took their patient census for several years, detailed patient census, descriptive analytics there, and we can look at that and we can see trends in that too, as we're just looking at what happened in the past. We took their summarized payroll information. Again, descriptive, something that happened in the past. I'm getting an average salary for different levels of nursing. I'm getting in different departments and that sort of thing, so I can look at the economics of staffing when I'm doing that. We took their scheduling system, so we looked at how the nurses are scheduled out for the next few months and the nursing roster for the next few months. And we put all that together into a predictive model that would say, during the next few months, this is the level of patients we can expect on a given day in these given departments. And then we can go from there into the economic model, taking the average salaries from the past and saying, comparing the different levels of staffing and the different way we'd need to staff between hiring people working overtime, staffing through a temp agency and some sort like that, to say what's the most economical mix of staffing and level of staffing that would satisfy the patient needs. So then we can isolate that best economic model, and then we could compare it from the most optimal level to what they currently have on their roster to what they need to do. So in this case, they were heavily overstaffed for that. Now that doesn't mean that they're going to subtract 14.45 people. That just means they're going to have a conversation about what our staffing needs really are. But now we've got a little data to support that. And that we also could build in this model, we built in the seasonality, so they knew that in the wintertime, you could select just which months I want to staff for. So in the wintertime, typically they would need more nursing resources because people would come to the hospital more because they're sick in the wintertime. And we'd see that trend throughout the year. So this was a kind of a very, well, I wouldn't call it a simple. There were, I think, 120 pivot tables involved in Excel to do this, but it was all in Excel. But it was descriptive, predictive, and a little bit prescriptive here, telling us maybe what we need to at least do, take a look at doing with our staffing. Again, that was an Excel model. There's tools far, far, far beyond that, of course. But this is just one example of things that people can do in their own organizations without hiring a statistician, without really spending a lot of money on this. Looking at it, then we're going to talk about a little bit more, some more fancy tools in terms of, and ways that we can do some predictive analytics. In this case, let's just think of A, B, and C as traits or products or something that this group of people have in common. And when we're doing this, we're looking at a little bit of correlation here now, where we're talking birds of a feather flock together. This is kind of the Amazon thing. We might be saying that people that bought A, B, and C also bought X. And they're looking at people that have bought A, B, and C, and they're looking to sell us X. Or X could be, if it's a bad behavior or a bad thing like a disease or genetics of some sort, we would be looking at people that exhibited all these other traits and be at risk for that either bad behavior or negative outcome, and we'd want to discourage that. But we'd be able to maybe predict who's most likely to have X in whatever way. And we can do that in a couple ways. One is very simple. We can just look at it and say, common sense approach. Yeah, people that A, B, and C seem to always have X too. And we did this in the banking world. Because if you had a checking account and a credit card and a car loan, you might have had a mortgage as well. So then we're looking at people with a Visa card and a checking account and a car loan, and we're probably offering them a mortgage. And there can be a progression to these things too. I mean, then you get into which comes first and things, but at a very basic level, that's what we were doing. Without any analytic tools whatsoever. That was simply a manual process and kind of a let's just say a common sense approach, conventional wisdom. We can also, with bigger data sets, we can also employ some statistical applications, whether it's SAS or SPSS or R, something that will build a predictive model where we load in all of these other variables and our target variable X, and it determines which variables are really the important ones to determine X, that really have the correlation with X, so that we can then put in everybody that doesn't have X and run them through the model, and it would kick out the people that are most likely to take X or to have X. And that's a rather simplified version of explaining R and SAS and these other tools. But in terms of pricing, SAS is thousands and thousands of dollars. SPSS is probably thousands of dollars, and R might be one of the cheaper. It's an open source, but it's still going to be some kind of money. But typically, you can get something, download R and run it on your desktop without employing it enterprise-wide. I just wanted to show a couple examples of descriptive analytics first. Okay, oh, I needed to be connected. I was going to do that beforehand. Let's see. Ladder 424.
And it's the same as the other one.
Crash.
Capital I in number 2. Capital M E exclamation point.
Please. Here we go. So this one is just causes of death. We have male and female, and then we can go through the different ethnic backgrounds. And I kind of like this. I just like flipping between looking at the different types of death. Of course, in early life, we get a lot of external causes, accidents, and that sort of thing, because kids don't usually get sick too often, but there's some. But then as we get older, it's circulatory, the heart problems and the cancer problems, etc. And when we flip over to the males,
So if you make it past 70, your cancer risk is like going down.
yes, it is. Yeah.
If it hasn't killed you yet, you're in the clear. Which is
Yeah,
over the hump.
And all of these tend to trend down eventually, except other. You got to watch out for that other after that point. But then I look at the males, and this is kind of a nice interactive graph, and I see things change quite a bit, especially this early part of life. When you watch that happen again, I think this can be explained with 3 simple words. Hey, watch this.
I thought it was hold my beer.
That would be another 3
20-year-old.
words. Yes, exactly. So as we see that, but again, this is all based on, again, historical data. This is descriptive. But from that, then we can probably predict some sort of the likelihood that you will die from at some point, and what point. And I kind of, as we go back here, I should probably switch this so I can watch my own mortality click by. And as we go, let's just do it fast so that we can see what happens. And you can build all sorts of neat models. And I've never built a nice animation like this, but with the right talent, you can make that happen. But it's just kind of fascinating. It's all, again, looking at death statistics and predicting at what point you're going to.
So what is these little balls?
These little balls are individuals dropping into the various buckets of when they're dying. When they drop off into these buckets, that's when they're dying. So they're just going to keep
statistics below.
footing these things through. So we're
Oh,
graphing up
yeah.
how many people are dying at certain ages here. And you'll see, I mean, people do make it out here. They got the outlier way out here is the oldest person to die in the U.S. Somewhere, must be in the high 100-teens. But we could waste a lot of time watching that. But again, now that's taking descriptive from the past, looking at probabilities, etc., turning into more of a predictive. And of course, life insurance companies have been doing this for years, and health insurance and other things here.
They don't like to share.
They don't share that. There we go. All right, let's go back and let's continue on with our PowerPoints here. Let's talk about big data for a moment. Big data is, again, that buzzword we hear everything about. So we're talking data from external sources from the internet and the world of things. And the big data is those sets of data that are just too huge to be managed by normal computer applications. You're not going to store all of and retain all of that data in a big data environment. You're going to sample that as it's happening. We're watching those clicks on the internet. We're watching the traffic on the web pages, etc. We're watching those purchases all over the place, and we're sampling that to see, statistically see what's happening in there. Because there's, in my world, I do data warehousing, so I'm piling everything into one repository, and we're storing that up and using that over and over and over again. With big data, we really can't do that sort of thing. There's just too much of it. Hence, but there's techniques to handle that through statistical analysis. And again, it's oriented towards predictive analysis, so that we can say, what are you going to do next? With all these clicks, with your travels through the internet, etc., where are you going next? What are you going to do next on that? And we're seeing that with the wearables. We're seeing the data come in and the interesting data that you get and the information you get back from that. And we're seeing that from the Internet of Things, and soon will be our grocery lists and everything will be determined by big data and predictive analytics. As I mentioned before, I think one of the most important parts about analytics is the presentation of the information. And with the tools we have now, we can present this not in lists of numbers. We can present it in simple charts and graphs, in visuals, so that people can look at it and understand it right away. So that they're not swimming in numbers, but they can look at it and almost, if we do this right, those charts and graphs are almost making the decisions for us. And we'll look at some examples of this as we go. But talk about the buzzwords again for the last few years was dashboards. Everybody wanted a dashboard, didn't care what it did, but they wanted a dashboard. Got to get me some of that. Scorecards, balanced scorecards have been around for a while, but we can build those using automated data tools as well. And the thing that all of these have in common is they're action-oriented. Again, they're pointed towards helping you find out the exceptions that you need to follow up on right now. Dashboards are, again, something you want to bring up in the morning, you want to look at it, you want to know, it's going to tell you how to spend your day. So let's look at a couple of examples. Now this is a legacy, kind of a legacy report. This would be what managers in the old days would get from their computer systems, and sometimes still do. You're looking at it, and you have to look at all these numbers individually, you have to find these patterns in your own mind, you have to almost go search for, you have to almost know the answer and go searching for the data to support it in this, or have a suspicion before you can make sense of it. And these are pages and pages and pages long if you're a big organization. I used to get 11 by 17 green bar reports like this at the bank. And they'd say, well, this is part of your job to review this. And I would say, I'll do that tomorrow, and I'll do that tomorrow, and I'll do that tomorrow. So I'd end up with stacks and stacks of firewood essentially in my office, because who had time to do that? And what we want to do is eliminate that research time by making it something more simple to understand. And this is a simple Excel-based dashboard. You can build a pretty good dashboard, a very functional database in Excel, just using the native tools that are in there without any fancy skills or any fancy statistical analysis. Really, these things are just built in. But the idea here, again, is very simple graphs, so you can look at them and see immediately what it's telling you. No real content on here. I just grabbed this one off the internet. In fact, this is one that I also use in a longer class as a bad example, because if you add up all the percentages on this pie chart, they don't add up to 100%. Really bad chart, but it's simple and it looks cool. So yeah, but we can do lots of things just with Excel, and even in Excel, you can tie different pivot tables together. You can take the results of a pivot table, dump it to a chart, and you can present all these things on a one-page dashboard sort of thing, so that you can go right to that and you can look at it. And we'll talk a little bit more about things with Excel otherwise. In a more sophisticated tool, this is a tool called Power BI. And you can generate some pretty good looking dashboards there. Again, what we want is just a small number of charts. You don't want to clutter this thing up too bad so that you're confused by that. You also want to know what you're looking at right away when you look at it. how many times have you looked at a graph or a chart like that last slide, for instance, and said, what am I really measuring here? You have to look so closely at the axes, you have to look at the measures, you have to say, what is this telling me? I don't know. It takes me 10 minutes to look at the little pie chart to figure out what it is telling me. Shouldn't be that way. It should be very easy to say, what am I measuring? And it says, how are we performing? Okay, when we look at this, it says total profit. We got a little spark line graph. We got profit margin. We've got average order quality. And so we're knowing that this is implying right away this is over time. So we're seeing a graph of this measure over time, whatever else. It should be consistent. And when I looked at this thing for the first time, I said, okay, what do we got? We got total profit. Obviously, we're dipping down here towards the end. Profit margin seems to be kind of consistently rising, or staying the same. That doesn't seem to be a problem. And by the time I got here, I was thinking, okay, average order quantity seems to be going up, but the only thing that could then result in that is probably either quantity of sales or total revenue going down. So you can see that peak and dropping, peak and dropping. So we have the consistency going across, but you have the different components of your financials right here. So you really don't need to look at the income statement for a 3-year income statement to figure out what's happening with your business. You can know that right here. It also tells you a little bit about those 3 years, and you see that drop off right there. Again, everything's consistent, everything's tied together, everything should be on the same time period, all the data should be related on a dashboard. And a good dashboard, again, you can probably filter it by something else, a different department, a different company, a different, and drill down into, I just want to look at, the United States sales and the United States operations or the international operations, so that you can say, filter this thing to just what you need to look at. And ideally, again, if something was wrong here, it would be in red. So you would click on that and then get an expansion of that. So you could drill into that data, and then you'd get a detail of what was in red, and something in there would be red. So now you're drilling farther and farther down into the granular data, and by the time you get down, every layer of that graph knows what it's telling you. So when you're down to the lowest level of granular data there, that's where it says you should do this. You really need to call your sales manager and indulge them. Essentially is what it's going to tell you when you get there. This again is Excel-based. This is a simple scorecard, fairly simple scorecard built for a hospital. And we can, if I open up the actual Excel tool, we won't have time tonight to do this sort of thing. We could explore it more. But we can filter through by the different departments. This just happens to be the intensive care unit that I grabbed the snapshot of here. In the scorecard, scorecards are typically numeric, but we can also still highlight where they're not meeting their goals. Again, scorecards are oriented towards your progress towards a goal or achievement of a goal. So when we got red numbers here, that's indicating on this, that's their key that we didn't meet the goal. You can see what the range is supposed to be here. It's supposed to be under 5% of overtime. Well, we were 5.01, 6.05, 6.3 here. So we didn't make our goal in that. And each department could have different measures, whatever was specific to them. Obviously that makes a difference in a hospital. But we can tailor, each one would have their tailored metrics. And we can flip this through for all the different month ends. Again, lots of pivot tables tied together, but fed from data from their hospitals, their McKesson system in the hospital. Why does all this stuff matter, right? Because we want to translate this into easily understood information, and preferably visual versus numeric. Again, most people can see what's happening when it's presented in a chart, especially if it's presented properly, rather than a list of numbers. So we're going to just get that. And because of that, sometimes then we're able to see those trends that are invisible when they're on one of the legacy reports, or if they're just buried in the data themselves. Sometimes it's not even if it's on the report. Sometimes it's relating two different pieces of data that you didn't put side by side before. And now you can see that somehow there's something wonky in there, and you should investigate a certain relationship in your data. One of the nice things is that we can, with analytics and with the tools I'm about to show you, and the processes I'm about to show you, we can bring in external data. Again, that could be demographic data, that could be government data like census records, it could be government data like property records, that sort of thing to bring in. Lots of public databases out there that we can incorporate into our own and line up with our own data so that we can see the relationships with the world as a whole. Okay, so let's just, now this is, I gotta wake you up a little bit again here. So let's just check to see for all your own organizations or any organizations that you might want to just think about right now. Let's just ask a few questions to see where you're at using analytics. So which statement in here, there'd be 4 or 5 of them here, which statement as I go through, just kind of in your mind say, yeah, we're doing that, and then stop when you know that you've achieved this. What is your organization's reporting capability? Don't use or cannot obtain useful reports. I won't read all of these to you. If I go too fast, raise your hand and I'll slow down. Number 5s? Who's at 5s? Where we get all the information we need in clear, concise, interactive online reports. We notice it's getting close. Okay, we're at maybe a 5. All right, how about a 4?
Well, I'm.
You're definitely a 4 then. Okay.
I'm closer. Our department's closer to 4.
Okay. And keep your hands up. So we got a 5 and a 4. 4 now. We got 4s. Okay. How about 3s, where we're getting a lot of stuff out of Excel, maybe assembling it from other sources. We got a 3. Okay. Some 4s and a 3s. Okay. And this is typical where we're getting something out of the computer system, but we're reformatting in Excel so I get those simple little charts and things, because we're not getting the charts out of our systems. All of our reports are standard from the computer system. Anybody there? No? Okay, and really we don't get much for useful reports. How's Brian Hoot doing on reporting?
Depends on what you want to report on.
That's the question.
Number 4, we are able to request customized reports and generate themselves.
Yeah, but you're a bunch of data geeks. You're geniuses over there. You should be able to generate your own
We
reports.
just don't have time for that.
That's
I think
exactly
we're too
right,
busy
yes.
generating revenue.
Yeah, there you go.
Who has time to
Precisely.
review it, right? Yeah. Yeah.
Good answer. Okay. Now, again, on the organization level, now, how do you use that in your decision making? So again, are you using data for your decisions, or are you just using data? So let's just run through the possibilities on making decisions with data. Take a glance and think where you're at. Any 5s? Any 4s? Who's getting? Where's your organization?
Actually, I was a human resource management consultant in my home country.
Okay.
Yeah. So during my working time, most of because we design like the compensation system or performance system for the client. Usually, like all the our solutions are based on the data exchange. Yeah. So that is we make decision for the client and for our own business based on the data and analytics.
Provide the dashboard and the predictive then.
Yes.
Yeah.
Oh, nice.
Great. Okay, well you correct me as I go through here then, because you're using this stuff too. So this is great. How about number 3s? Where we do use it to.
That's one.
Yeah, we're getting there, right? We're using it and we're comfortable with that. How about number 2s? I like number 2.
Yeah.
That have already been made.
Yeah, because the number of times I was asked at the bank to, can you give me a report of all the members in this particular city? And it really meant, we want to put a branch in this city and I'm looking for data to support my decision.
Because the brain.
Because I've already almost hired a contractor, but now I got to justify it to the board of directors.
Give a report that makes us look right.
Exactly. Yeah. And again, I think we're probably not ones here, but we're. And then, okay, now you yourself. How are you doing on analytics? What's your use of data and analysis? Probably not there, okay? I'm not going to ask you on this. I'm just going to let you determine your own level of comfort with analytics. If anybody wants to volunteer, you can go ahead. Is there a data whiz in here? Al, you do this stuff.
I'm a little different. Right? I'm trying to encourage our city to be more analytical driven, so I actually design and build a dashboard that gather up all the measurements that I collected from different sources. So I really wanted to encourage our city to be more data driven. Because in our community, we don't have a common dashboard. We have various dashboards. And so I built a kind of a dashboard, but it's more to do with you get what you measure, that mindset versus this kind of analysis that you make decision based on data. It's more like, you just declare that you want to, like for example, DMC, right?
What's measures?
Yeah,
what's
DMC
measured
says
gets
30,000 jobs.
Yeah.
Or this much growth income.
Yeah.
So what are you measuring to ensure that? That's more from that
Okay,
perspective.
cool. We'll talk. I've
Yeah.
seen your stuff
Right.
in the past, so.
So it's a little different.
Julie, did you have a?
I was just thinking how it seems to me that data-driven decisions are great in that they help take away the emotion, the politics, the person
Bingo.
behind it, right? So you can have a little bit more of a really objective
Correct.
decision making.
Correct. A little anecdote on that. I mentioned in the hospital example, we were talking about the nursing staffing. Talk about a potential difficult discussion there.
Yeah.
And I would never go into that discussion and say, my model says that I need to reduce it by 10.75 nurses. So, boom, 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 boom. No. What that is, that's a conversation starting to say, why is it telling us this? And why am I hearing from other sources that we don't want to do that? Another hospital example was the ambulance service. Because the ambulance director was saying, I need 12 trucks. And the administrator was saying, why do we need so many trucks? We don't have, we've got to have a truck available at any given point. And he was in the sense of, if they wanted to have a truck available at any point, any minute of the week, to go immediately upon notice, they needed 12 trucks. But if they wanted to cover 99% of the minutes in the week, they needed like 6 trucks.
Yep.
And going down to 95%, you were down to 4.5 or 5 trucks. It just went down significantly when you didn't have to cover all the time. So that's a conversation where it's, okay, can we get to 99 so that we only need 6 versus 12? And can we work with a neighboring hospital? How can we cover this 1% of the real rare cases when we need 12 trucks out on the road? That kind of thing. I learned a lot about ambulance service as well. That's one thing about this kind of work, is you learn a lot about different industries, because you're always learning a different domain. And I started every project really stupid, and it's really fun because I can sort of get to maybe only sort of stupid by the end of the project. It's kind of fun. So again, now this is some things about recognizing when analytics could be useful and when working with data could be useful for you or your organization. These are some simple little clues, and I think we'll find symptoms of our own organizations in these. But when you have many different systems that you use to run your business, and you're getting different reports from different systems, sometimes conflicting data out of different systems, and you're wondering what's going on here, okay? Limited history. When your system only stores a year's worth of transactions or a year's worth of sales or something, you've only got that period of time to look at. You don't have a whole long time. At the bank, when I started in 1991, 1991 at the bank, I hate to think that, they kept 3 months worth of transactions. That was all. Storage was expensive. So I could only ever look at trending for 3 months, and as soon as an account was closed, it stayed on the books on the system for a year, and that was purged out. So I could never tell what happened to those loans we made 5 years ago. I didn't know. They're all gone. So I started squirreling away data into tables back that were loans from year-end 1994, loans from year-end 1995, and then I could use that 4 years later. I could go back into those databases and pull those things out. So I was building my own history over time. And before I realized what we were doing, we got into data warehousing, and then I fell off the deep end of this stuff. All right. Your system probably has granular, unformatted data. Transactional data can be useful, but a lot of times you need to know how to put this data together in order to get the patterns out of it, and in order to aggregate it. Again, limited ability to aggregate, and you're getting large volumes in there in your system that maybe exceed Excel. Exceed Excel capabilities. By the way, I love Excel. I hate Excel.
It's a love-hate
It
relationship.
is a love-hate. Because I would be just dead in the water without Excel. But people use Excel, and I'm guilty of it too, push it way beyond what it should be done, what we should do with it. And we make it do things that it's not designed to do. It's a big calculator is what it is. But boy, we make it act like a database. And all those models I was telling you, they shouldn't be in Excel. If you could possibly do it someplace else, put it someplace else. Afford something else. But if you don't have anything, Excel works.
How about have you encountered Google spreadsheet, usage of Google spreadsheet these days, or in your experience?
I don't. I'm the old dog up at the collider, and I don't use Google spreadsheet, but I would be willing to be educated. So
It's not similar, it's
It's
not
not as
quite
capable
nice.
as Excel.
Yeah.
And
In terms of spreadsheets, Excel is pretty much boss.
and ubiquitous. It's just everywhere. Everybody has it, and it's okay.
Well, actually, I use Google
You're
spreadsheet.
good. Okay, so everybody. Yeah.
What are the
Not
benefits?
as much as other people probably.
Just sharing, maybe? What are the
Collaboration.
No,
benefits?
it is
Sharing is-
yeah,
is-
it's
Sharing the
Well,
benefits.
it's
Yeah.
not, I mean, it really is Excel on
On the internet,
and maybe not as many folks, but people are building a lot of apps,
Right.
in
And-
associated with
And within Excel,
It's actually quite powerful.
exactly. Excel, and I'm sure Google Spreadsheet.
It
All
does
these things
some
are
of-
hugely powerful. When I was in grad school for getting my master's in business intelligence, we used Excel in our data modeling classes, and we essentially used VBA to tie pivot tables together and such, and build our models that way because everybody had it. They didn't have to buy a tool just for going to school with. But it was, I went there kind of expecting to use more powerful tools, but we ended up learning a lot about writing VBA, which actually has given me a couple projects since, so this isn't bad. But when we're getting spreadsheets you'll see people do this in a department. They add a new column for this month. They add a new column for this month, and you're building data by columns going this way. It's a way to accumulate it, but it's really hard to use once it's put into those columns. I like data that's stacked up this way. Everything is vertical with the same characteristics. You might have a date over here to tell you what data it is, but the measure is over here and everything is vertical. You can do a lot of stuff with that. Or even, the other thing is in Excel, different tabs for different ones. Yeah, and you can tie all that stuff together, and you get graphs and stuff out of an Excel. So it isn't bad, but when you're starting to do that, you're creating hours and hours of work every month to do that. And now I start to say you can probably pay for that work in 6 months with a data project. And if you're cutting and pasting into Excel from other reports, you're probably getting close to where you're going to want to automate something. And especially if you're getting inconsistent information from multiple sources. Then you want something, a single source of truth. You want to connect that data between the different sources. So that's where we're going to go to, and I'm going to cover the entire topic of data warehousing and business intelligence in 5 minutes.
Excellent.
All right? Where we're going to go now is, before we get there, I want to talk the data science hierarchy of needs. We all know about Maslow's hierarchy of needs, right? Going from food and shelter all the way up to self-actualization. Well, the self-actualization of the data world is artificial intelligence, machine learning, those automated tools that we're hearing so much about, and that's kind of the holy grail. Not many people are there, and my whole world exists at this level. Before I don't even get into any projects at this stage that use machine learning or artificial intelligence. I've never been on a project that's gotten there, newer organizations that have. Hopefully I will. I'm looking forward because I would enjoy learning about that sort of thing, but I'm not there yet. And again, our talk tonight is probably going to be focused down in here because I got no experience to get us up into the artificial intelligence world. That's a cool thing that I like to read about, but I'm not going to go there tonight. And again, so much of it starts with, do you have data? Can you collect the data? Can you store the data? Can you move the data around? Can you get it, can you put it where you need it? Can you archive it? Can you clean it up? Can you prepare it and organize it in order to be used? And that's an art to organizing data. We hear the term relational database. There's an art to putting it into a format so that you can aggregate it and summarize it and slice it and dice it and move it around and identify those trends and actually make it kick out those reports. And then once it's organized, then we can get the analytics and the metrics and the answers and the information out of that data. So we're working here. My world is typically called business intelligence. Business intelligence automatically combines that data from those different computer systems. So we're pulling it all into one place, and that's where we're organizing it to do reporting from it. Keyword here is automatically. We like this to happen by itself through a computer script or program of some sort or an application of some sort on a schedule, so we don't get humans in there to mess things up. Because when we're cutting and pasting from Excel, it can be done, but anytime we introduce humans into the equation, we're going to get some problems. Gotta have the computers do this stuff. But again, it brings it all from different places. We'll show you how this works. It's also known as, in various terms, business intelligence is kind of the hoity-toity term that's been used. Now that's kind of going away and people are just talking about analytics now. But for the last several years, decade or so, it was business intelligence. Before that, way back in the 80s, 90s, it was decision support, data warehousing. We'll describe what it is, a little bit information management. Now we just call it reporting and analytics, and people can probably get a better handle as to what it is. I never really liked the term business intelligence, but this is what it is. When you have a computer system, it probably has, it definitely has a database in that computer, supporting that computer application. In that database is data. In this case, we have yellow data. We might also have a different computer system that has blue data. And some of the people in there, some of the entities, Bob, is in both of these. But not everybody's in both of these. Okay? And we might even have a third one. Again, with green data now. Again, could be different people, could be some of the same people. What we want to do is we want to combine that into one place. So we'll run this through something we call extract, translate, transform, and load processes. So that we're pulling the data out, we're matching it up, joining it up, and loading it into one place. Now when it's in one place, we can already do some things. Because now we can look at what Andy's got in different places, Bob's got it in 3 different places. We can see, we're starting to get an idea of the total relationships with these people, these customers that we have here. And in fact, that's one nice thing, because now we can start to do just computations on this. Because we've got everything into one place, and when we do computations on that, we can add data. So now we not only have our original data that we've got, now we're building more. Just from, the sum of the, what is it? The sum of the whole is, the whole is greater than the sum of the parts. Is that the way it goes? Because we're going to make this whole grow more than the original data. Because now we can bring in external data. Again, that census data, the government databases, or whatever we want, internet data that we can bring in, and we can plug that in and link that up to our own internal data. So now we're getting an idea of how our customers might relate to the population as a whole and do some demographic analysis. Then we might do some statistical analysis on what we've got here, and we might be able to add further data on that. When I was at the bank, we would look at their interactions over with all the ATM machines and basically predict who's going to use that sort of thing. So we were able to put that data in there as a piece of data, not just as something that somebody had to assume every time. They could see it right there. This person will do this. Then we're going to write this thing off to an archive. Might be a data warehouse, some kind of archive, some kind of repository. We're going to put that data in there. And over the next periods of time, we're going to add history to that repository. This could be daily, this could be real time, almost near real time, as we would say. Almost every second we could be putting data in here. We could be putting it in a month end. Whatever it is, we're building a history of it. So now we can do trend analysis. And now we can maybe do more statistical analysis, because now we've got history on this. We've got behavior over time. Again, adding more data. And then ultimately, we can kick out simple reports, charts, good information out of that. That tells us what we do when we find out that Andy, in this case, needs some attention. And we kind of want to keep an eye on Ellie. But this is a case where I don't have to spend all that time looking at all my other customers, digging through all those reports, because it's just telling me, you better give Andy a call. Cool? Business intelligence and analytics in less than 5 minutes, I think. Getting close. And again, what we kind of hanging the label on this, data sources, 3 different data sources. There can be many data sources. The extract, transform, and load process, doing some computations, bringing in external data, statistical analysis, building a history or an archive, doing some trend analysis, again, more statistical, and kicking out some sort of dashboards and reports. Okay, so why is this useful? Let's start at the very basics. As you're loading this stuff in, you're testing this stuff, and you're finding data that doesn't match the traditional ranges, or that it's outside. You might find future dates in historical transaction data. You're going to clean up your data as you go through this process, because the aberration is going to pop out at you now. I've found so many different ways to spell Rochester. But when you run it through and you try to run a report and summarize it by city, you get 13 different ways of spelling Rochester. You say, you have some data problems, and source data problems. Again, when we add those columns there, we're creating data. We're creating labels, we're creating new information from stuff that didn't exist before, doing that trend analysis. The discovery is when we're in there, we're aggregating, we're pivoting, we're slicing and dicing, and all of a sudden we're finding something. You can do this manually, or you can build these models that will do it for you. You buy the fancy models that will do it for you. But you're finding things that you just didn't notice before, because it's actually easy to manipulate the data, as opposed to pages and pages of green bar report. And again, if we can get to the stage where we're using that to predict what is going to happen next, and give us an inkling about what's coming, whether it's our sales, whether it's our customers, whether it's weather, anything else, so that we can say, take proactive action so that we can get there, that we're not caught by surprise. Okay, so this is going to be, there's slides in your handout. We're not going to do that tonight. I never did intend that. But this is a little exercise that if you wanted to, if you're really interested, you could go through this even by yourself to say, let's find a dashboard that we wanted to build. What kind of information what are we gonna measure? What decisions are we looking to make from this? Where do we get the data? So as we would try and pick a topic for our information, some questions that you can ask. And in a normal 3-hour class, we'd sit there and we'd go through this exercise, to pick what are we going to measure, why do we want to do this, and why would it be useful? And we go through these next slides in order to come at this. So these are in your handout. We'll just look at the topics. So we're going to say, measure something. What are we measuring? What are the entities in your organization? What are the nouns? Where is the data right now? Do we even have the data? What do we got to do to get the data? Do we have to record it? Do we have to turn on some monitors? What do we need to do in order to collect the data in the first place? We got to organize that data. And what kind of tools are we going to use? What kind of software and what kind of people are we going to need to do that? It might be yourself, but it might be Excel, it might be something different. We got to clean that data up. What kind of data problems are going to go? And I talk about outliers and things on here, but we're not going to do that tonight. How much history? Put everything together, and then at the end we actually draw that dashboard that we've been aiming at. And we're just drawing it on paper. We're not building this in Excel or anything else, but we're putting that dashboard together so that we can imagine, get our minds thinking about how do I want to see this? And what's the easiest way to see this? One thing I tell people all the time when we're building dashboards is you want a high ink to information ratio. High information to ink ratio. You want lots of information with very little ink. So you don't want to see a lot there, but it's got to tell you a lot. So you want to simplify on that. Briefly, some of the leading analytics tools. This is a tool, a report called the Gartner Quadrants that they do every year, and they look at all the business intelligence tools. And just to expand it, they have different quadrants as far as the niche players, the visionaries, the challengers, and the leaders. And this has kind of been consistent up here. Actually, people have been moving out of the leaders area. Far and away, Microsoft has the market out there. Tableau is kind of the Cadillac. In a longer class, I have a demo of Tableau, and I can show that later on too, or pass along the link. It's in here, I think. Whereas Tableau is a beautiful tool. It's an expensive tool, but boy, you can pivot your data all over the place with that, and it's a great visualization tool. Microsoft is kind of the F-150 instead of the Cadillac. Everybody has it or can get it in terms of, they got a tool called Power BI. Download it free to your desktop, or you can buy an enterprise version of this, but it can use almost anything as a data source. You still have to organize your data. You still have to know how to put the data together. But boy, like that one dashboard we looked at, you can tool.
It's beautiful.
It's beautiful, and you can build a dashboard in minutes with that thing if you know what your underlying data is.
With that, can you bring it in from the different sources?
Yes.
And what type of files do you typically need to upload into that?
You can have text files. You can have, and you don't necessarily have to upload. You can put it on the cloud, but it can point to different locations as well. So you can have Excel spreadsheets. You can have text files. You can have tabs or comma delimited, whatever. CSVs. Yep. And you could have SQL databases. You have Oracle, any kind of databases, any kind of ODBC databases you can link to. So there's a lot of sources that you can connect right through Power BI. And I mean, you're going to want to spend some time with it, just like you have to spend some time with Excel to really learn Excel.
So like, can it pull in XML feeds?
I think it can. I actually think it probably can.
It's the enterprise version.
It is probably not your desktop.
The premium.
It is really a cool tool. Again, you want to be careful because you can get carried away and build. I saw 2 people build charts on this in the past couple of months, and one built very simple, easy to understand charts that were useful. And you can look at them and say, this is what it's measuring. And other people had multiple axes on their charts, and it was cramming a lot of information, but they used a lot of ink. And I spent a lot of time just going, what does that line mean? I shouldn't have to ask what that line means. It should be very apparent what it is. If you're doing that, if you have to spend a lot of time, more time figuring out the chart than figuring out what it's telling you, you've built it wrong. Okay. So if you really want to just do a simple data project, you need you or somebody that you can influence. You need some Excel, do some pivot tables, learn how to link them up. It isn't all that hard. Attach some slicers, which are really menus, so that you can pick by the month, by the department, whatever else, and filter by those different departments on those pivots. Tie them together so that you can build a dashboard or just simple pivot charts out of that. You can get a lot of that right out of Excel. And of course, we have Excel. And again, when it comes to the data, nothing says that you can't copy it out of another report, another electronic report, and paste it into your Excel, which is what I had to do with that hospital census, which is a lot of data. But again, you're limited to how many rows? Is it still 1 million? It's a lot of records, but you can get beyond 1 million in a hurry when you got granular records. Or you can work with somebody in the IT department to let you write a query into the database to pull that data right into Excel. Then you can pivot it and you can do all kinds of things with it at that point. And I would recommend that over copy and pasting, obviously, but it still can be a manual process. Now, speaking of that, when we get to that stage, one of the hardest things is just getting access to your data. Even when it's your own organization, a lot of times it's, will you give me authority to the database? And they're going, no, nobody gets in our database. And well, how about just read authority? Can you give me read authority? So that no, because you might see the payroll information, or you might see the employee information, whatever. Okay, so you got to get all over those hurdles before you can get into anything and actually start using it, Garrett.
So how would you recommend pulling that? In what format?
Actually, within Excel, they have, it's called Microsoft Query. So a lot of times you can write a query, right? You set up a data connection to that database, and you could pull an entire table in just like that, just boom, and it pulls it right into the columns, rows and columns, and it have your column headings and everything right there. Mm-hmm. So once it's in there, you can pull it into an existing pivot table. So you can have all your filters and everything all set up on that already. Once you pull it in, build your pivot table, then you refresh the data. It just boom, dumps it in there again, and now it's new. And you can do more things with it. But you can also write a tailored query, because you probably don't want the whole table. You only want five columns
on a relational database. Microsoft Excel is generally two-dimensional, but your relation gives you different axes.
Correct.
So then how do you...
That's where, correct. So you might pull in transactional data on one tab or one pivot table. You might pull in customer level information on into another pivot table. But that transaction tab or table probably has customer number on it. So now you're pivoting, summarizing that down by customer. You're linking it up over to this pivot table, and you're doing a query between the two on customer. So now you're getting customer totals, from your transaction, but you've also got the age of your customer, the gender, the preferences, and other things. And then you might have something else over here that can join to part of that customer level. And that's where Matt's talking about a relational type of model. That's where Power BI really comes in handy, because Power BI is going to take each one of those raw data dumps. Either it's going to connect right to the database itself, which is what I would recommend, or you're going to pull them in as separate data dumps and use Power BI within Excel itself to connect everything up. I got to keep moving on here. We're not going to have any time for questions on that. If you really want to get into a complex project, then you're going to have to get more resources in here, where you're building an enterprise-wide data warehouse or something like that. So then you're going to get into, you need a business analyst to find out what the requirements are, what your reporting requirements are going to be, what are you going to measure, all those questions that you're going to ask. You have to do some data analysis so that you know what the relationships are between the data. You're going to need IT involved, probably an architect of some sort to lay out how is this data going to come together and what's the most efficient way of processing this data and storing this data, and a reporting analyst again to tell you who they are. And you probably need some other software applications. I do most of my work in SQL Server. When you buy a SQL Server license, you get SSIS, which is the integration services. You can pull it in from different sources, even Excel spreadsheets or whatever. It's kind of this is the precursor to Power BI when it comes to that. Then you get Management Studio, so you can write your queries and your stored procedures, etc. in a what do you call it? A report generation tool, whatever, and then you can do some simple data analysis there, but you can set up scripts that will run automatically. Then you get SSAS, the analysis services, so you can put it into a data cube, which is predetermined relationships and pre-calculated hierarchies in there. And then you can get SSRS at the same time, which is reporting services. And that's kind of, again, a prequel to Power BI, but that'll let you run the interactive reports. So you get all of those things. People think they're just buying SQL Server because they're buying the database, but they get all of those tools along with it if they just put them to use. So a lot of times they're hidden there, they got them, they don't know them. All of that stuff. This is a little graphic here called I call it Iceberg for BI Iceberg, but it's really when people sell you a tool, they're going to sell you this, the part that you can see. They're going to sell you the dashboard, the glitzy, the stuff that sizzles. Mm-hmm. And wouldn't it be great? You can get this great dashboard, you can get this great reporting functionality and whatever. They quote you a price for this. The price does not include all of this. And the biggest cost of a data project is the ETL process of connecting all those databases, doing the data analysis, bringing them together, moving the data around, putting it in a repository, paying for the storage, everything else, all these things. Servers, networks, governance, personnel costs to maintain. You got a DBA, you got some other things. Which software tools you're going to buy to do this? Getting the data access, etc. There's a lot of stuff that goes on under the surface in a data project. And a lot of times somebody, CEO will go off to a convention and buy a glitzy tool and say, here, run me this by next week. You're going, what? This is a 6-month project to get there. And it's going to cost 10 times what you just paid for the part up above. So be very careful about that. I'm not saying you shouldn't do that. I'm just saying be prepared and be aware that there's going to be ongoing costs with this thing as you do it. Okay? How much time do we have left? Negative time for questions? I'm available for whatever questions, but it depends on what time you want to take up here. How much?
Doesn't matter. People have to leave, then feel free. Otherwise, hang around, ask Craig questions. We'll be here till 2 a.m.
Sounds good.
Thank you.
Want to build a database?
Yeah, let me open my laptop.
Yeah, exactly. Let's start building something there. Let's build some pivot tables, shall we? Oh, God. Please no. The worst thing would be doing it on a Friday afternoon. But I will, if there's any questions or whatever, happy to address anything tonight. And I'll hang around here for a while, too. Or give me a call. If you want to give me a call or email me with any questions, go ahead and take a card and maybe go with that. But most of you know where to find me on a daily basis anyway. Okay.
Thanks so much.
Thank you.
Thanks,
Thank you for coming.